Everyone, and today we'll be seeing one of the problem from Geeks for Geeks. It says next element with greater frequency. The problem goes like, given an array ARR of integers, for each element find the first element to its right that has a higher frequency than the current element. If no such element exists, return -1 for that position. So let's understand with an example how is it what is it that they are asking us. So we are having an array. So we do have an array. The next element to 1 is nothing. So we have -1. So again they want no such element exists. So that's a -1. That's the reason. So you have 2. Now for 2 they have written 1. Why? Because it has one has more greater frequency, because one is occurring 3 times whereas 2 is occurring 2 times. So that's the reason. Multiple time occurrence of 1, that's the reason I'm taking 1. So when I'm on 3, multiple both are occurring greater than 3 times. Like 3 is occurring only once, but 2 is occurring multiple times, 1 is occurring multiple times. So whom to choose? So it goes ahead and chooses 2 because it is just next. So we have to consider two things. We have to consider things like we don't not only wanted the higher frequency, but we also wanted to have just next. So two things here kept in mind, and if you don't have anything, we return -1. So cool. That's the case. What we are doing over here. So how we can solve this? Let's first take an example. I'll take this example itself, which is over here. 2 1 1 3. Okay, sorry. 2 1 1 3 2 1. So yeah, this is an example. I'll quickly write down indexing 0 1 2 3, and this is 5. So these are nothing but index, these are nothing but actual value. And what do we want it to do? We wanted to understand first of all frequency. So let's have a frequency map. So 1 is occurring how many times? 3 times here. So 1 2 and 3 times occurring. 2 sorry 2 is occurring 2 times, 1 is and 3 is occurring 1 time. Quite interesting. 1 2 3 and 1 2 3. So yeah, now we wanted to go ahead and we wanted to find. Now we have found the frequency. Look, okay, I'll quickly jot down the frequency first. How many times 2 is occurring? You'll say 2 times. 1 is occurring 3 times, 3 times, 1 time, 2 times, and 3 times. So this is nothing but a frequency. Now what I'm saying is, initially let that there be no element, and I wanted to just understand what's the next index. I don't want a value, but a next index who has greater frequency. What I mean with that? So I'm currently having a frequency 3 over this column. Now with this frequency 3, do I have next element which would have a greater frequency? Obviously not. There is no such element. That's the reason I'll not do anything over here. Let's consider index 4. I have a frequency 2. Next greater frequency. Yeah, I see 3. Cool. I have 3. Nice. But what's the index of 3? 1. I'll write here 1. Now I have 1. Greater frequency, do I see? Yes, 2 with the index 4. Quickly go ahead and write 4 here. Now I'm at index 2. Do I find anything like any subsequent or any number on my right who has greater frequency? I don't think so, because I see 1 2 3, but I don't see 4 5 6 7 which would be greater than this 3. So I will keep this as it is because it doesn't contribute to anything. Same with this 3, it doesn't contribute to anything. Next is nothing with for them. And for this 2, next is this 3, nice, 1, which has index 1. Cool. We got the index. What do they want, by the way? We got the index, but they don't want index. They want actual value here. So they want actual value. We got the indices. So we will just convert these indices to their actual value. So that means these were the elements, and I'll say actual result, or result actual for their corresponding values. So it is 1. What's the actual value at index 1? It's 1 itself. I don't have anything here, so I'll not keep anything over here. So index 4, what is at index 4? It's 2. What is at index 1? Again, it is 1. What is here? It's nothing, so I'll write here nothing. So 1 minus 1 minus 1 2, 1 minus 1, 1 minus 1 minus 1 2, and this is what they want from us, and this is what we have delivered. That's interesting, and that is how we solve the problem. Few things we have required for a while, because we wanted to store the frequency, we wanted to store the index, and we got the actual result then. So we 2 additional data structures we want, and obviously this data structure is, one is map, which would be integer, which would do nothing but it would just map out the frequency. That's it. Okay, a better variable I'll choose, frequency, frequency. Yeah, here I'll assign with new hash map to it. Okay, new hash map, just populating. Now wanted to populate this map quickly. I'll do it, so I'll make this as A, and here frequency dot put for this I. If I'm already having this, that means frequency dot get or default, or sorry, my bad, 0. If I'm having this, give me that, else give me 0, and I'll plus 1 to that. At this point, I'm sure that map is filled. Now, once the map is filled, what I wanted to do? Let's see. Map is filled. I have the actual things. So this is, I'll say, mark it as done here. This is also done because we already have frequency. I haven't created a frequency array. Do I need a frequency array, by the way? No, because I have frequency map. So this is also done. Now it's time to do this. So let's do this one, where we go ahead and we generate next greater index frequency. So what I'll have is, I'll have an integer array which would be next integer greater frequency. Okay, it's too long name, so I'll just make it simple, next big index. That's the gist of it. It will contain n. What is n? You'll say final int n is nothing but the size. Now my task is to fill the next big index, and that too based on the frequency. So frequency based next index, obviously, but within this next index I wanted to take care of the last index, because this last index has no next to it. I'll just hardcode it right away. So next, okay, quickly copying this one. So n minus 1 for this is minus 1, and now that I'm taking care of n minus 1, I'll go from n minus 2, and I'll do it for n greater than or equal to 0, I minus minus. Doing it in reverse order because I wanted to first understand what is my right, and then I can say to someone else that, hey, your right is this, because I myself have been traversed with that position over here. So yeah, what would be my next index? So next possible index can be I plus 1. I'm saying that, hey, maybe index 4, maybe your next bigger index can be 5. Don't worry about it. So yeah, how I'm going to deal with it is understand that hey, if next is actually smaller or not. How I'm going to deal with this basic if statement that hey, if next or else what I'll say is frequency of next index or e dot next index is lesser than or equal to my current frequency. What is my current frequency? Frequency dot get a of I. If this is possible, then I'm saying that hey, I have got the smaller, and I'll choose. Sorry, I have got not smaller but larger, and that's the reason I'll choose it because my current is lesser. In case my current is greater, I don't want that. I want it to go to the next one, and I'll keep repeating going to the next one on right until I find no larger element. So I got larger element on right, I'll go to that till the moment I am not just adequately small enough. What I mean is, let's suppose with this array, so I have here 100, I have here 1, I have here 2, 6, 10, 70 and 100. So for setting up the value 100 or the next, I'll take it 101. What I'll consider is I'll check 1. Hey, if 1 is not possible, then what I'll do is next of 1, next of this, next of this, next of this, and next of this, until and unless I'll find it out. If in case I'm having 60 over here, so 100, 60, what is greater of 60? Greater of 60 is 70. I just went from 60 till 70 directly. So I have skipped all those steps and I went till 70 here. So that's the power of this algorithm. That's why I'm taking next of index is equal to a of or next big index of next index. For next index we have just took next, so that's a better thing. Okay, cool. But there might be a chance that someone is saying that hey, I don't have any bigger number. That means next should not equal to b minus 1, and this condition should be true. These two things needs to be checked, and then we can go beyond. And this, my friends, okay, this, my friend, is going to happen not once, not twice, but until and unless we will get this. So it's a while loop, not if else. And once we are out of this while, we are sure that hey, next is for sure at a correct position, and now it's a correct position. So next big index of this current element I should be equal to next index. Cool. Now we are done with that. Now that means we are done with storing this. We wanted to store the actual results. Actual results is quite simple because you have an index, you get the value. That's it. And for the actual results, what I'll do is I'll have array list of integer, which will be res is equal to new array list. Again, I'm not taking interface, I'm taking a concrete class because they are expecting concrete class to return. I don't know why, but they keep doing this. This is not a good practice, but yeah, this is what it is. Usually you return the abstract things and then you go ahead. But anyways, res dot add what I'm going to add. Okay, I'm going to add a number, and a number would be from next big integer. So int incoming is equal to next big index of I, and if incoming is equal to -1, again your index, your value is -1, so you cannot take out the actual value from it, so you'll keep it as -1. So it will keep it, I'll keep it as -1, else I'll take an actual value, I of incoming. That's it, and we are done with this, and I'll return the result. So let's compile this code for checking any compiler errors upon this. Okay, there is one, a semicolon missing right at 46. Yes, now check it. Okay, we have few errors over here. What are they saying? This is interesting. My output gives no -1. That is so weird. Maybe this can happen because I haven't considered this less than or equal to. We want strictly greater than elements, so we'll use less than or equal to. So let's submit this one. If in case if it was okay, no less than or equal to, the less than would compile. So yeah, this was one of the problem, and this, in my opinion, we have also respected the time and space complexities over here, and this took hash and stack data structure. Now you'll say, hey, where did we use stack? We didn't use, my friend, this extra thing, the next index array which you have used, we have used it as a stack. Remember, we just went from left to right for each operations, so we skipped all those this, so, and we acted this is a monotonic stack. So you can consider this as we have 100, we have 60, we have, then we have what, so for 100 we have 60, we have 70, and we have 101. So it was a monotonic stack all along, but only the problem was we didn't used it in this way, we used it in iterative way. So yeah, this was about it, and for more such optimization trick tips hacks, click the video on your right, and I'll see you in the next one.